This is 7.2a of algebra. So we're going to start working with some exponents. And if you think of like 3 squared, that's just 3 times 3, right? And let's say 3 to the 4th. Well, that's just 3 multiplied 4 times, right? 3 times 3 times 3 times 3. Well, what if we multiply those together? 3 squared times 3 to the 4th. Well, 3 squared is just 3 times 3. And then we need to multiply it by 3 to the 4th, which is 3 times 3 times 3 times 3. So how many 3's do we have there? Well, we have 6 3's, right? So this is 3 to the 6th. The other way we could have gotten it was by adding these two exponents, right? That's 3 to the 2 plus 4, which is just 3 to the 6th. So here's our general statement. A to the m times a to the n is equal to a to the m plus n. Right, and here it is written out in long form right there. So let's try that. So we've got 8 to the 3rd times 8 to the 6th. Well, 3 plus 6 is 9. So this is 8 to the 9th. What about this one? We need to add those. We've got negative 3 plus a negative 8. I think of negatives in terms of owing someone money. So you owe someone $3, and then you need to owe them another $8. Well, then you owe them $11 in total. So this is 0.5 to the negative 11. But are we allowed to have a negative exponent? No. So we need to move it. So it's 1 over 0.5 to the 11th. And that would be your final answer. Our last one, we're using 3 numbers. You're still going to do the same thing. Negative 3 plus 2 plus 6, which gives us, that's negative 3 plus 8, which gives us 5. So this turns into 9 to the 5th. Okay, let's try using variables. So first thing we need to do is we need to multiply our coefficients. So I've got a 5 out front and I've got a 3 out front. So I need to multiply those. 5 times 3, that's 15. And then I need to figure out what exponent needs to go on my x. I've got x to the 4th here, I've got x to the 9th here, and I've got a plain x here. If you have a plain x, it's probably helpful to write in a 1 for your exponent so you don't forget about them. So we've got 4 plus 9 plus 1, which gives us 14. So this is 15x to the 14th. Let's try this one. So we need to multiply our exponents, right? We've got negative 4 times 7 times 2, which gives us a negative 56. And then we've got a c and we've got d's. So we can only combine the c's together and then combine the d's together. In this case, there's only one d there, right? There's no other terms with a d in it, so it's not going to have to combine with anything. But one other note is that we like to put things in alphabetical order. So c is going to go first with some exponent, and then we'll have this d squared. So to figure out our c's, we need to add. So we've got 3 plus negative 2, which is just equal to 1. So this is c to the 1, or you can just leave it plain. And our last problem. So first we need to multiply the coefficients. There's just a coefficient of 1 on those first two terms. So our coefficient is just a 12, right? 1 times 12 is just 12. And then I got to combine my j's and I got to combine my k's. J needs to go first, right? I've got a 2 here. There's nothing written here, but that means I've got a 1, right? So 2 plus 1, that equals 3. So we've got j to the 3rd. K doesn't have anyone to combine with, so this is just k to the negative 2. We're not allowed to just leave it like that, though, right? We need to move it since it has a negative exponent. So the 12 and the j to the 3rd can stay on top. And we need to move the k squared to the bottom so that we get a positive exponent. And that right there would be our answer. Okay, so now we're going to work in scientific notation. This just happens to be a story problem about molecules of water. So we'll use the numbers from that. But the main takeaway is multiplying with scientific notation. And before we do that, let's review scientific notation. So scientific notation is some number, so like let's say 3.2 times 10 to some exponent, so maybe 10 to the 3rd. Okay, that's in scientific notation. 1.4 times 10 to the negative 2. That's in scientific notation. What our rules are is this first number can't be smaller than 1, and it has to be smaller than 10. So it can be 1.1, that's okay. 1.0 is fine, but we can't have like 0.9 times 10 to the 4th or something. This isn't okay out front. The other one that we can't have is we can't have like 12 times 10 to the 3rd. That's not okay. If we have a number that's not okay, we need to move our decimal. So right now our decimal is here, right? So we need to move it over so that it's between 1 and 10. So that we get 1.2 times 10 to the something. When we went from here to here, we started with 12 and we went to 1.2, so we got smaller, right? So then over here, we need to get bigger. So our exponent was 3, now we're going to make it 4. And this would be in scientific notation. If we had something like 326 times 10 to the 7th, our decimal's right here, so we're going to have to move it once. That's still too big. Twice, so we get 3.26. So we got smaller twice. So over here, it needs to get bigger twice. So this goes from a 7 to a 9. Same thing works as if it gets smaller. So let's say we have 0.36 times 10 to the 4th. Right, I need to move it this way so that this turns into 3.6, right? So that got bigger just once. So over here we need to get smaller. So this will turn into a 3. Okay, so now we're going to try multiplying them. So we're going to do 200 times 1.13 times 10 to the negative 7th. And we're going to do 9.98 times 10 to the 5th times 3.34 times 10 to the 22nd. And we need to multiply these. So how we're going to do this is we're going to multiply all like the front numbers kind of. So we're going to multiply these numbers. And then when we do that, so we're going to do 200 times 1.13 times 9.98 times 3.34. And we get 7,500, and we'll say 33. Then I need to figure out what the exponent is on my 10. So I've got negative 7, a 5, and a 22. So negative 7 plus 5 plus 22. Well, that's negative 2 plus 22. So this is just 20. So this is 10 to the 20th. But that's not in correct form, right? That's not in scientific notation. So clear some room over here. We've got 7,533 times 10 to the 20th. Here's my decimal. I need to make it smaller. So I need it 1, 2, 3 times so that I get 7.533. So this got smaller 3 times. So then over here, when I figure out my exponent, this needs to get bigger 3 times. So this is going to go up to 23, right? I added 3. And then this would be my answer. And there's your homework.